Lecture 7, Forecasting Supreme Court Decisions, and this is part 2 out of 4. Okay, after having an introduction to our case and the data set, now let's introduce the methods that we are going to consider in this case. So we are going to apply the card classification regression trees and also random forest. So these two actually are tree-based methods. So they are flexible and data-driven methods. So in these two methods, actually, we are going to determine an outcome using splits or logical rules on independent variables. That means we are going to partition our data set into increasingly smaller and more homogeneous subsets using logical rules on independent variables. Okay, so this is our approach here. So in these two methods, unlike the regression models, the outcome is not linearly dependent to independent variables. Okay, and cart and random forest can be applied for both continuous outcomes like linear regression and also categorical outcome like logistic regression. Okay, and at the end, the most important advantage of cart and random forest methods is being interpretable. Okay, so yeah, we can interpret the outcome by having those logical rules, how this outcome has been made through those partitions and having the logical rules. Okay. So here we have an example on how we do the splits in CAR. The first split could be defined on independent variable of x. So we say, okay, if x is less than or equal to 60, then predict the red. Otherwise, we have more conditions, we have more splits. So if x is greater than 60, then we have another split or another condition on variable y. So this is another independent variable y. So if we say, okay, we have this condition, if y is greater than 20, then predict gray. But if it's less than 20, then we need to have one more condition or one more split number 3. And here we say, okay, if x is less than 85, then predict the red. Otherwise, we predict gray. Okay, so this is how we split the data set using conditions, logical rules over the independent variables in order to have the partitions or subsets in the data set, and by having that we can predict the outcome for each partition. Okay. So here we have the tree for our example. So here we have the first split or the first condition. If x is less than 60, if it's yes, then we predict the red. If it's no, we have the second split or second condition, and it's about the variable y. If y is less than 20, if it's no, we predict gray. If it's yes, we have another split or condition, and it's over a variable x. If x is less than 85, if the answer is yes, then we predict the red. Otherwise, we predict the gray. Okay. Here we have another example. Here we want to classify whether applicants to a job position will be given an interview. So here we have a data set of the last 5 applicants. So as you see here, we have 2 independent variables and 1 outcome variable. So outcome variable is the interview. It has 2 outcomes, yes or no, and the independent variables are about the highest level of education and having experience. Okay, so as you see here, for MBA degree and having experience, the outcome for interview is yes, but some college experience, yes, it's no. So this shows somehow having higher level of education is important. And then bachelor's degree, again, bachelor's degree, experience is no, then the interview is no. But if it's yes, experience, it's yes. So this shows having experience is also important. And here we have one case, PhD, and experience is no, again, interview is no. So this confirms that having experience is important. So now let's build a tree, a classification and regression tree based on this data set. So if we want to summarize our analysis by the dataset, we observe that having no experience is too important. So no experience means no interview, right? And for the education level, we observe that having at least bachelor's degree is important. So by these rules, we can build our tree here. So the first split would be on experience. So does he or she have previous work experience? If the answer is no, then no interview. But if the answer is yes, then we take a look at the education level. So does he or she have at least a bachelor's degree? Again, if the answer is no, no interview. But if the answer is yes, we have interview. So in building any tree, always if the condition of this bullet is true, we should move to the left by denoting the yes. So all yes options would be on the left side of the tree, and the no's would be on the right side. Okay, and the split should always be read from top to bottom, and the observations in the buckets are described by all of the splits up to that bucket. Okay, so that's the general instruction for building a tree. Okay, so in the code, each split is always defined based on a single independent variable. Okay, so uh, if we consider an independent variable for a split, that means that variable is significant and important. So we never use insignificant variables for a split. So that means always the card will include the significant independent variables. Okay, and the splits divide uh, observations into smaller groups called leaves or buckets. So yeah, each partition based on the condition is called a bucket or a leaf. Okay, and each bucket includes observations of one class. I mean, homogeneous as possible. So, for example, in our previous example, we see all applicants with no experience in one bucket, and then all applicants with experience but lower education than a bachelor's degree in another bucket, and in the third bucket we have all applicants having experience and enough education level, right? So yeah, we see somehow homogeneous cases or observations in each bucket. Okay, so now an important question is, when does card stop splitting? So there are different ways to control how many splits should we generate in the card method. So one way is by setting a lower bound for the number of points in each subset. The number of points, I mean the number of observations, the number of cases in each bucket, in each partition. So in R, we have a parameter that controls this is when this is min bucket. So min bucket means the minimum number of observations in each bucket. Okay, so the smaller it is, that means the more splits will be generated. And if it's too small, then overfitting will occur. I mean, if it's too small, then we will have super pure homogeneous buckets, so it will be overfitted method. Okay, and if it's too large, model will be too simple and accuracy will be poor. So yeah, as you see here, we need to somehow obtain the optimal level for main bucket in order to have better splits. Okay. So we may try several different parameter choices to limit the number of buckets. So one approach that can be applied here is called cross validation technique. Okay, and another way is considering a validation set of data. That means here we'll have three subsets of our data set. The one would be the training set, the second one would be the validation set, and the third one would be the test set. So in the validation set, we will try different values of the parameters, I mean different value for the main bucket, and see which one is working better. And then by having that, we say, okay, we have our final model, and then that model will be used for evaluating the performance on the test data set. Okay. Okay. After building a classification tree, let's see how can we make a prediction. So at each leaf of the tree, we have a bucket of observations, right? And so here we may have both outcomes like affirm and reverse in one bucket. Okay, so for each leaf, we can calculate the percentage of points in one group. If we have the category called outcome 0, 1, and in our example, affirm, reverse, then we can see, for example, let's assume that we have 12 observations in one bucket, and 10 of 12, the outcome is affirm, and for 2 we have reverse. So 10 over 12. So the probability of having a firm in this bucket is 0.867. Okay, so usually like the logistic regression, we will set a threshold to obtain our prediction. For example, we can say, the default value here is 0.5. What we can set another threshold like the logistic regression. So if we consider 0.5 as the default value here, that means we are considering the most frequent outcome as our prediction. So in this example, it is over 0.5. So for that bucket, our prediction would be affirm. Okay, so this is for category called outcome variable. But if we have continuous outcome, like the variables, dependent variable in linear regression model, then the prediction for each group or bucket would be the average value of the dependent variable over all training points that were classified into that group. Okay, so yeah, for each bucket, we will take the average of the outcome variable over all the observations that we have in that bucket, and that will be our prediction for that bucket. Okay, and yeah, since in CART, all observations that are classified into the same bucket, I mean the same group, since they are homogeneous, then we will have same prediction for any observation is classified into that bucket. Okay, so now by this introduction on the CART method, now let's build a CART model for our dataset in R. Okay,